Okay, nuclear transmutations are kind of like decay processes, but these are when, if you think about it, transmutating, we're trying to mutate those elements into other elements. We can induce these as well. So decay processes are natural, but nuclear transmutations are when we induce nuclear reactions by colliding two nuclei. Okay, they could be neutrons, they could be elements, it can be whatever. But if I am specifically trying to induce a nuclear reaction by colliding things, this is how we actually made those large man-made isotopes. So if you're thinking of the periodic table, right, the stuff on the bottom, a lot of those are man-made, and we made it by essentially shooting neutrons at other particles. Okay? So we're trying to make these things. The first, I think this was the first person to do this was Rutherford. You might remember him from the gold foil experiment where he shot alpha particles at a gold foil and saw that some of them bounced. So he was working with some nuclear chemicals. What he did is I have a nitrogen 14. If I shoot an alpha particle at it or a helium nucleus, okay, I end up with oxygen 17. So this was a transmutation reaction. I mutated the nitrogen into oxygen, but it also gave off a hydrogen. So you can see that these elements are not balanced, but the masses and the proton numbers are. Also, though, this isn't a type of decay process we've talked about. We've never talked about giving off a hydrogen. That's not a decay process. So this is a transmutation reaction. Okay, so balancing works exactly the same way. Example number 3 says identify the missing isotope from the nuclear transmutation below. You're just going to look at the top number, bottom number, fill in the blank. So give these a try, give it a pause. Okay, and then you should get 12,6 carbon for this one and 272, 111 Rg. Works the same way.